So in section 4, we're going to talk about more concurrent lines. And remember, concurrent lines are 3 or more lines that intersect in one point. So they all intersect at the same place. Let's just review a few of the concurrent lines that we discussed in section 3. The first one was our circumcenter, and that's where the circumcenter is where we have perpendicular bisectors. So we're not only bisecting the sides of the triangle, but the lines are also perpendicular. And the point where all 3 of those lines intersect is the same distance to the angles. So remember, when we bisect the sides in a circumcenter where it's perpendicular bisectors, then that point is the same distance to all of our angles. The incenter is where we're bisecting the angles, and that point of concurrency, or where they intersect, they're all the same distance to all 3 of the sides of the triangle. Right, so the first one that we're going to discuss today is our median, and you'll see it's very, very similar to what the circumcenter is. There's just one major difference. So the median of a triangle is a segment whose endpoints are the vertex and the midpoint of the opposite side. So it's almost identical to our circumcenter. The only difference is this line, this median, does not have to be perpendicular. All right, so when we were just bisecting the other sides of a triangle, it's now just our median. The perpendicular bisectors is the circumcenter. All right, and all 3 medians are always concurrent, meaning they're all going to intersect at one point. Now, just like our circumcenter and incenter had special traits and special properties, our median has a special property as well. So where our medians intersect, so that point of concurrency, that is called the centroid of a triangle. Right? So the centroid of a triangle is the point of concurrency for your medians. Right? So when we say it's our centroid, it's where all 3 of our medians intersect. And this centroid is also referred to or called as a center of gravity, meaning if you try to balance a triangle, you would have to balance it at its centroid. So where all 3 of the medians intersect is where the triangle can balance. All right, so now, just like there's special formulas for our circumcenter and incenter, or special properties or traits, our medians have a formula. And what our formula is, it says DC, so that's from our vertex to our centroid, meaning where our 3 medians intersect. So the distance from our vertex to our centroid is equal to 2/3 of the entire segment. So if DJ was equal to 12, that means DC would have to be equal to 8. It is 2/3 of our entire segment. All right, and that holds true for all 3. So EC, so from this vertex to our centroid, is equal to 2/3 of the entire segment GE. And then the last one, FC, so from this vertex to the centroid, is equal to 2/3 of the entire segment as well. All right, so now we're going to do one problem with this, and then there's one that you'll do for me. Before you get started, now that the centroid or the medians are very similar to the circumcenter, you need to be very careful to the directions or very careful to the drawing. So it does say find the length of the median. So it flat out tells us that this is our median and not our circumcenter. The way that we could tell even without those directions is all of these segments are just bisected. Not once does it tell us that any of these lines are intersecting at 90 degrees. So we know it's not our circumcenter. All right, so then it tells us that XA is equal to 8. So it gives us that XA is equal to 8. So XA is the segment that goes from our vertex to our centroid, where all 3 of our medians intersect. So we know, based on the formula, that XA from our vertex to the centroid is equal to 2/3 of our entire segment. And this entire segment here that we're talking about is XB. It goes from that vertex to the midpoint of the opposite side. So we know it's equal to 2/3 of XB. So now this asks us to solve for the length of XB. So now we plug in, we know that XA is equal to 8. So we say 8 is equal to 2/3 of XB. So now if we want to solve for XB and get rid of that 2/3, we will multiply by its reciprocal. And remember, reciprocal is where you flip the fractions. So you say you love me, but now you flip in like reciprocals. So we multiply each side by 3/2. So then the 3 and the 3 will cancel out, 2 and the 2 will cancel out, and we're left with just XB. All right, now 2 goes into 8 4 times, so we can divide 8 by 2 to get 4. And now we're left with 3 times 4, or 12. So we know that that entire segment, XB, had to be equal to 12 units. All right, So this is the only example that we're going to go through here, trying to keep this video a little bit short. So now there's going to be one example. And now what I want you guys to do for this last example is I want you to create a Google document, and I want you to share it with me. All right, so create a Google document, and I want you to share it with me. This is something that you will probably keep doing going forward. It's going to be shared instead of being on Remind. So this one document you can just keep using over and over again. So you can title video section 5.4.1, and then you can say your answer underneath. Right. So the question that you guys are going to get is with this diagram here: if AP is equal to 18, what is KP? So once again, I want you guys to create a Google document. And then I want you guys to show me as much work as you possibly can. So just type in the formula that you would use and then give me the answer. All right, so share a Google document with me, title, label the video that it is, so 5.4.1, and then you can give me the answer underneath. Right, and that is it for this video. And then there's one more for this section, and there's going to be another video that we're going to talk about the 4 different concurrent lines that we've discussed.